Hi, it's teardown time again and deja vu. You may remember the Cypress automatic activation device for parachuting that I did a teardown of many years ago, and I'll link it in at the end of this video and down below if you haven't seen that. And that was an older model of this, as I said, Cypress automatic activation device it's called. It's designed for parachutists, and it's a bit of life-saving equipment, hence why this will be a very interesting teardown, because the design and qualification of a life-saving product like this is a real big deal. So what it's designed to do is it's got a pressure sensor in here, an altitude sensor effectively, that continuously measures your altitude. And if you're a parachutist and let's say you jumped out of your plane and you went, I don't know, unconscious for some reason, I'm sure there's a variety of reasons why, you could lose consciousness, or you're just too busy enjoying the view and you forget to pull the cord. Well, this thing will detect the change in air pressure, i.e. your height, and it'll detect your rate of fall and all that sort of stuff. And at a predetermined altitude, which you can program on this little doodad here, it will automatically cut your cord, your either your reserve or primary parachute. I'm not exactly sure how it actually loops in and configures through to the system. It comes with a little cord here which interlocks with your chute, and there's a pyrotechnic charge in here and a very sharp blade in here that then cuts through your loop, which then automatically pulls your parachute. And the stats on this thing is actually very impressive. They've manufactured over 200,000 of these things. There's been 123 million jumps using this thing, and it's saved over 4,000 lives with 0 failures that they're aware of anyway, so if you believe the marketing department. But anyway, that's a lot of lives saved. So this is a real critical bit of safety equipment for parachutists. Now, this is the Cypress Expert unit here, and you'll notice that it's very, slimline compared to the previous one, which I actually tore down. But it basically it has the same looking controller like this, and it looks like exactly the same pyrotechnic charge cutter on here. But they do have the Cypress 2 now, so I'm not sure if this is the Cypress 1, I guess, or if this is actually the Cypress 2 and the one we tore down previously is the Cypress 1. I'm not actually quite sure. Anyway, it's the Expert model, manufactured in 2004, so it's quite old, and I've got to actually thank Angus Dorby for sending this one in. It's been on my teardown shelf for, I'm not going to say how long, but my miscellaneous devices. It was sent into the mailbag for a teardown. So this should be a fascinating look at the progress in engineering design. I don't expect spectacular progress, but small refinements between the previous generation of this unit, which was very interesting teardown. It was potted with a re-enterable gel and used primary lithium batteries and like a real old school microcontroller that's super rugged. And Angus said that this has to meet, of course, EMI requirements as well. So yeah, it's going to be interesting to take this puppy apart. Unfortunately, the battery is dead, and I'm not sure what battery it used. I assume you have to take the end off because it's got a filter on here which is actually replaceable after getting wet. How wet? Well, I assume if you fall through clouds or something, get some moisture or whatever, do you have to replace it every time? I'm not sure. If anyone out there actually is a parachutist and uses one of these things, let us know. Now, by the way, they do have a new model specifically for wingsuits, because wingsuits descend at a much lower rate than a typical parachutist, basically in free fall pretty much. Wingsuits, you can fly around, you can stay up there for, ages and descend much, much slower. So obviously, like the rate of change and things like that and your requirements are very different. And critically different to a parachute model. So they do actually, this is the parachute model, so they do have a specific wingsuit model. And also, it's important for the pilots of the parachuting planes to actually be aware that these devices are being used, and Cypress actually publish guidelines for the pilots that they're not to descend faster than a certain rate, not to drop below a certain preset altitude, and all that sort of jazz, because the last thing you want is a whole bunch of parachutes going off in the back of the plane, all charge has been cut anyway. I'm sure they wouldn't, just deploy, because there's no wind to actually deploy them. But still, it wouldn't be pretty, I'm sure, if a whole bunch of parachutes went off in the back of the plane. So if the cords got cut. Now with the display unit, you can actually preset your like the altitude. You can put it in different modes, like expert mode, and there's a student model as well, or a student mode, and a fast freefall mode, and various other different things. And you can preset the altitude that you want it to release at. Now I think the previous model didn't have automatic calibration, because pressure, of course, atmospheric pressure is going to change all the time as the weather changes, and that's how it determines your altitude. So the last thing you want is for you to calibrate in the morning, and then you go jumping in the afternoon and a big low pressure systems, or high pressure system has come through and has completely changed that, and you could be off by, I don't know, I haven't ran the back of the envelope numbers. You could be off by hundreds of meters, I'm sure. So, it could be a big deal. So this one actually has, this new model actually has automatic calibration. It actually measures the air pressure twice per minute, and then it takes an average of that. So it's always continually knowing that you're on the ground, because you're not falling. It's obviously, you could use software to detect that, obviously, and it auto-calibrates your ground level, so you don't have to worry about, before you take off, actually setting this thing. So you press once and it switches on and it goes through a self-test routine, and then it goes into auto calibration mode. It's always measuring the ground atmospheric pressure level, so it's auto calibrated. So that's pretty cool. Now obviously this thing's going to be pretty well sealed, so you can see these grommets around here, and I'm sure we'll see these in the teardown. Looks like we've got a little choke in there, and this connector here, let's take that off. Whoa, look at that. It's got an O-ring for nice moisture sealing on there. It's a TRS type one, but it's like, it really is, I'm sure it's carefully designed and engineered to be quite reliable, because you need a super reliable contact. You don't want, vibration and everything else. I'm quite concerned that there's no lock-in mechanism on there. Maybe they heat shrink that after it's gone on or something, and this one hasn't had that happen. I don't know if anyone, it requires quite a lot of force to take it off, but still I wouldn't rely on just that O-ring seal to do that. So I'm not sure what the deal is there, but anyway, it's very nicely constructed. All the cable ins are rated, and all this stuff. I'm not sure if there's any like government regulations for these sorts of things, but basically Cypress are #1 in the business, and so they do take, like, the safety compliance of all this sort of stuff extremely seriously. So yeah, I'm sure it's they probably invented their own standards, and if there are any other regulations, then I'm sure they follow that as well. But yeah, it just oozes quality, this thing. It's super rugged, as you'd expect. So anyway, let's get inside this thing. We've got 4 screws on the end here and 4 on this end, so hopefully it all just comes apart. I assume it's going to be potted like the old one, or at least part of it. There's going to be probably like a lithium primary battery in here, because you don't want any of that rechargeable rubbish. When you've got a super reliable product like this that you have to ensure works, you want the best quality and probably certified batteries as well, lithium primary ones. You'd probably, like Panasonic. I remember when I worked on underwater stuff which used D-cell lithium primary cells, we would specifically buy them from Panasonic, and they'd actually come with a certification certificate that they're actually, these batteries have been manufactured to X compliance and tested and everything else, to ensure that we guarantee that we're going to get, the 10, 12 or 15 year battery life, or whatever it is we required at the time, and it would still have sufficiently low ESR and capacity to trigger, in our case, a sensor, a heating element which actually burst a flotation bag of something on the ocean surface, which then caused it to sink to the bottom of the ocean. Okay, that looks like a T3 Torx, little self-tappers. So don't know how often you'd have to replace the battery in this thing. If it was anything like the previous one, I think it was, for the compliance life, or the service life of the thing. The previous one used large, I think they were D cells. Have to rewatch the video. Oh, I'm not sure what's going on there. How does your filter come out? Oh no, the filter just unscrew. Oh yeah, just unscrews like that. There's the port for our pressure sensor, typical like a gauge type port with the extended nose on that. Okay, managed to get that off. Just got the screwdriver in there and just pulled it off. This is the end bit, and there, see the O-ring around there. That's what you expect to prevent moisture ingress. Oh, and we're in like Flynn. There's the end of it down there. We've got some sponge. Oh, that's a hard cell. That's a hard cell foam. Yeah, I'll get that end off. Ah, there we go. There we go. Yeah, we've got a hard cell foam on there. Like the previous unit, we have a soldered shut can for everything. So, yep, very similar to the previous one. So, there's your RFI compliance right there. Oh, something. Got a doodad. Is that that's a MELF. It's a MELF resistor for all you MELF resistor fanboys. Card carrying. There we go. Why there's a resistor on there, not sure. External? What would be the purpose of that? Anyway, this is interesting. Check this out. They got a wire soldered onto the can here, which goes over to this board here, which has a couple of little SOT23s on it. Are they little transistors or are they diodes or whatnot? But yeah, it goes over to here. And what is going on there? They have this external and then 3 wires going back into, well, actually, no, onto that other PCB up the top, which has that MELF resistor. So some more hard cell foam in here. No wuckers, so they're keen on their hard cell foam. Anyway, it certainly doesn't have a user replaceable battery in this thing, as you'd expect, but of course the microcontroller can be ridiculously low power, and the LCD takes bugger all, and the pressure sensor, I can't offhand, it's been so long since I've dealt with pressure sensors, but it only powers up, as I said, twice a minute or something like that, so presumably when it detects that you've gone up in altitude and then you're starting to jump, I presume it does sample faster than twice per minute, so it goes into sort of like a higher power mode. But even then, you know, your power consumption from it probably uses CR123, but not your traditional bump and then contact ones. You don't want contacts in here. You want for the utmost in reliability for all these mission critical applications, you want welded contacts directly onto the primary battery. So looking at the size of this thing, I'd say, probably 2 CR123 lithium primary batteries would be the go. Anyway, yeah, not sure what that protection doodad is. Especially like it comes out and then like shield and then goes into there, some sort of ESD protection or something. Why it's not internal, why it's external and not internal, I don't know. Oh, no, I just noticed those wires don't go onto that PCB. They go through like that. That's a little bit how you doing. But, of course, these things don't move once they're all in place. So it's no problems against the, wear against the fiberglass or anything like that. But, yeah, and then the other one, just goes, this is the activation, the pyrotechnic charge cable, and it goes through there as well. I'm not sure if you can see that, but it does go through a hole in that PCB there. So there's really nothing else connected to that board except that MELF resistor. Still don't get it. Ooh, this is easy to come apart. I just did that with my finger. Ta-da! Oh, more hard cell foam. So if you see the previous video, I highly recommend it, then you'll know that that was all re-enterable potting gel, and it was horrible, horrible stuff. So they've gone for the hard cell foam in this case. So that's interesting, but we should just be able to peel off this can quite easily. Well, the good thing is that it's not one continuous wrap. It just has these plates on here like this. So we should be able to get the iron on there and simply remove all these plates. Sweet. Too easy. In like Flynn. Cut out for a cap there. This is much easier to get into than the previous one, I can assure you. My finger's going to burn before it releases. Tune in next week. Oh, the foam's going to come off. Oh, look. Oh, no, we've still got some of the re-enterable potting gel. Hang on, I'll show you in a minute. This is going to be an interesting teardown. Well, it already is. I think there's some bloody tab there. Okay. Here we are. Oh, no, that's not a CR123. There you go, single battery. Makes sense. They didn't have enough room for anything else. You can see the re-enterable potting gel there. It's always fun, icky stuff to play with, but I've used this before. It's really good because it means that not only does it prevent moisture ingress onto your boards, but it means that you can get through, you can stick your screwdriver through it like this and then adjust your pots on your board, which I've had to do many times, and then when you pull it back out, it seals shut again. So it's really nice stuff. It's called re-enterable potting gel. Oh, geez, this is not going to be pretty. Anyway, there's wires running snaking all over the place. Didn't expect that. And there's our micro. So the hard cell phone, that'd be thermal insulation would be my guess, although why it's not, on the sides and everything else. I guess you just need it over those parts and it was on the end, just to provide some thermal insulation on there. Oh, the battery just fell out. There you go. Yep, welded tabs on there. No worries whatsoever. There you go. That's an ER1850 to 87. Is that? No, that's not the date code. Anyway, I'll measure that. See if there's any juice. No, absolutely not a sausage left in that puppy. So, wow, completely drained. Didn't expect that. You'll notice an interesting penetrator system going through what looks like a metal, can on the backside of that of the PCB there, and they've got these penetrators which go through that. Wow, they've gone to a lot of effort there to terminate those wires onto that board. So that's interesting. Looks like, the bottom of the board has the pins that stick through, and they've got some sort of penetrating system. And that's why this won't peel off, because I'm not sure I can see that. There's actually a soldered connection down to what looks like from here. Anyway, requires closer inspection. Looks like a some sort of like SMB package device. But anyway, that's soldered down to there. It's annoying. There it is, LXC 226, is it? Upside down, so all the electrons are going to fall out. And they've got an SMB package across both of those pins, and this little bit of tin copper wire going up, which was then soldered over to the can here. So that's pretty how you're doing. I'm not sure what the deal is there. Geez, a bit more engineering thought required in that. Because, you don't want to be doing that sort of stuff in a production environment. That's just silly. And a couple of these Mylar sheets have fallen out, so they were probably... were they for the end? I don't know. They were insulating something. Anyway, you can see a second SMB device down there as well between some pins. So, design afterthought. Perhaps they needed some extra protection. I assume there's some sort of, Transorbi type thing. Aha! The wire's going straight through the metal there. I thought, oh, geez, that's not a good thing to do. What if, you're pulling the wires through and they get... accidentally nicked. The insulation gets nicked. Well, it looks like they've actually got some reinforcing on the edges of that. So they've actually, they're making a smooth entry hole there. So nice attention to detail. One thing we didn't look at are these external penetrators here. And I can't pull on those wires. So they obviously have quite a deal of strain relief. And if we get in there and try and, can we prise that out perhaps? Prise that off? Nope, that's pretty darn solid. Wow. Oh, there's one thing I just realized, and that the pressure port on the back here, I thought that would have gone directly to the sensor, but it doesn't. It just goes inside the unit on the end here, and then it just snakes around, and bingo, there is your pressure sensor. Of course, there'll be no re-enterable gel inside that. And there you have it. Offhand, I don't know if that's a custom jobby or it's a Bosch or something. They were big in the pressure sensor market back when I did it, I think, if I recall correctly. Anyway, and that's like an SMB ceramic part on the base of that. And then with the port on the top, of course, there's no re-enterable gel inside that. You have to be careful not to get it in there. But there you go. Geez, they've got one big ass ceramic there, don't they? And then a micro, which has some sort of test marking on it, as in programmed, probably. But yeah, and then we've got some pins on top. That'd be a test port. Does seem to have something. Oh, no. Wow. They do actually have re-enterable gel inside the pressure port. The pressure can be transferred through that? I guess it can. I never gave that a thought. I just assumed that they wouldn't have done that. Wow, that's fascinating. That there's the re-enterable gel in there. I assume it's the same stuff as this. Feels like it. Wow. It's one way to keep your moisture out of your pressure sensor, that's for sure. The other part over there, is that the same? Yeah, LXC226. The odds of me slicing my finger open on some aspect of this can, well, confidence is high. I repeat, confidence is high. There's another case ground connection there. They're taking that. Oh no, that bugger's off. I thought that went down to the PCB. So the internal goes out over to here. Well, sticky business. It buggers off, comes out the red wire. It looks like it goes right up the clacker of the... that's probably for the shield, I'd say. That'd be for the... is it for the shield? No, it looks like it goes into there. So the braid on that's already connected to there, but they've obviously got another internal wire going up the clacker right up inside here. So... that's interesting. They're really taking all that very seriously. All the, shielding and whatnot. For all you re-enterable gel aficionados. Oh, look at that. Oh, it's good stuff. And you can see why I said, if you got through there with a screwdriver and you want to adjust something, and then you pull it back out, you can see it sort of reseal itself. Oh, go for the money shot. Look at that. Oh, beautiful. Re-enterable snot. This is great. Yes, it is as fun as it looks. And that looks like an MSP 430. Sorry about the crudity of this. It's really hard to see that. Yep, I do believe that's an MSP 430. So that's not surprising at all, because you need a super low power micro in there, relatively, well proven and stuff like that. Now, I don't know how long the MSP 430's been around, but it's been around a long time, so they would have chosen a proven part that's, fully qualified. But the interesting thing about this is that if you read a lot of data sheets for pretty much all electronics components, not in every one of them, but a lot of the times the manufacturers will put in, this device is not qualified for use in life-saving and or medical devices. And of course, this is a life-saving device. Now, it's not that TI won't sell you the part, or you can't just buy the part from, DigiKey or Arrow or some other supplier, but it's not qualified. So if you want to have a qualified part from the manufacturer, which, is likely Cypress wood, then they would have to actually get a written permission from TI saying that, yep, this is used in a life-saving device, and they might have extra qualifications for the part and things like that. Do they have the industrial grade in here? And, other things that are, tricky compliance issues when you're talking about that. But anyway, yep, MSP 430, and really not much else. It's got the internal flash, of course. There's no external E2 prom or anything like that. That's, storing any parameters or anything like that. So it's all internal. And there's our sensor down in there. Offhand, I don't know the brand or anything from that. So if I can find any details, I'll edit it in. But yeah, nice ceramic base on that, that's for sure. But it's interesting. There's not much in there, is there? Now, from the physical looks of this, it appears to be a barometric pressure sensor from TE Connectivity. Now, they're a big manufacturer of, quality pressure sensors, but it's in this 12-pin ceramic package. You can count the pins on there. This is different from their lower range pressure sensors, which are basically 8-pin jobs. So I found one of their 12 range, one of their 12-pin ones that actually has a microprocessor in there as well. It's got software calibration points, it's got an ADC, and it outputs digital words, digital data. So yeah, that's but that one doesn't seem internally to be the same thing. So I'm not sure what's going on, because I cannot see the multiple die in there, for example, like is on the data sheet for that one. So I bet it looks for all the world like a TE Connectivity one. More searching. So in any case, that's going to use a Micro Machine silicon piezo-resistive sensing element in there. And yes, you do actually buy these, or you can actually buy them transparently gel filled. So it's very likely that with the gel we saw in there is different from our re-enterable potting gel from the outside. So it's probably, specially designed gel to be pressure transparent, I guess. Is that a thing? I guess it is. Anyway, it helps prevent moisture ingress into the sensor. And as for tearing down this thing, this looks like it's like fully potted on the back sides. I don't like my chances of getting that apart easily. Anyway, there's probably just a little micro in there driving the LCD, and that's it, because it'd just be like serial up the clacker here. So nothing terribly interesting in there. What we're interested in about is all this stuff in here which we saw, and that is fascinating. Thank you very much, Angus, for sending that in. And it is a significant advance to the mostly through-hole one we saw previously, and it runs on a single lithium primary cell. They probably get these, qualified from a rep. You don't just buy these from the Shenzhen market when it's, mission critical, life-saving device like this. So yeah, I'm sure there are, properly qualified cells and everything else. So yeah, they want to cover their ass there. And the interconnection system is all custom designed and stuff like that. And it's all very nice. There's a lot of thoughts gone into moisture ingress into this thing, and it's got the replaceable external filter thing which you're supposed to change if it gets wet. I'm sure moisture's probably not a problem. And with all the hard cell foam, they're doing some thermal isolation and things like that. I doubt that there's another temperature sensor in there. I don't know whether or not you'd bother. Maybe a little SOT23 temperature sensor might be in there, but there's nothing special. I don't think this is a combination sensor. I think it's just barometric pressure, and that's it. But apart from a few little hacks on here and stuff like that, and some interesting, penetrators, but they've put a lot of effort into shielding and stuff like that. And as I said, qualifying something like this, not sure of the regulations behind these, if any. If anyone knows, please leave it in the comments. But yeah, they've refined this over many years, and so even with the few little how you doing hacks, they're supremely confident in these things, as are the people who use them. And as they said, they, saved 4,000 lives with 0 recorded failures. So very, very impressive. And yeah, they would test the crap out of this and qualify them. So that's why they basically just make one product, or two if you count the wingsuit variant of this. And, really, they're a one product company. Basically, they just specialize in this. So yeah, I'm sure the design and testing and qualification of this is all the big deal. But yeah, they went to a lot of effort in there to make sure that this thing is as robust and as reliable as possible. I'm not sure what the lifespan is given, 15/5. So maybe it's 15 years ultimate battery life, 5 years operational or something like that. I'm not sure what the deal is there, but yeah. And obviously once it's past its service life, you throw it out, because then the battery is going to be flat like this one. I'm not sure why this is completely flat. Would have expected some juice left maybe, but yeah, you got zippity-doo-dah. Anyway, thank you very much, Angus, for sending that in. It's a fascinating look at a bit of life-saving technology, and there's more engineering, a lot more engineering and qualification that goes into this than what we can see in the teardown here, but hope you found that fascinating. If you did, give it a big thumbs up, and if you work on, if you work at Cypress, please let us know. Let us know the insights that goes into behind the scenes of something like this, that obviously they've designed to be super, super reliable, and the software, they would pour over every line of code in that software. So yeah, you can bet your bottom dollar there's no bugs in that, that's for sure. Anyway, hope you enjoyed it. Catch you next time. Alright, I know you want to see me blow this pyrotechnic sensor. I'm sure it's going to be nothing spectacular at all. It'll just go pop, and a blade will come out at, I don't know what sort of force, and cut a string. Now, there doesn't seem to be any, any boost sort of stuff in there, so I assume that there's just a driver transistor which connects it directly across the battery. I've measured the coil in here, or whatever it is to, ignite the pyrotechnic. Charge is 1.5 ohms, so I'm just going to hook it up to the power supply here, 3.6 volts, and then activate it. Let's go. All right, let's give it a shot, shall we? Switch it on. 3 amp current limit. Don't want to goof the current limit. Here we go. Way! Beautiful. So I guess you can chalk up another successful activation after all this time. Yeah, it's like more than a decade old. Still works. I'm not sure if you know exactly how the little pyrotechnic charge works in there. Please let us know. Do they have a spring at the end of it that seems to releases some little mechanism holding it back, or something like that, or whether or not it's the force of the charge or whatnot? It's not a very loud pop. It's more of a little crack. I don't know how to... You can hear it on the video, but it's not very loud. Actually, check out the back of this. This is interesting. It's sort of like melted. It's melted the string. Like, yeah, there it is. Anyway, oh, can we see it? No, we can't see through there again. So you can really see the angled blade on both sides of that. And of course, it has to be angled. It's got to go to a sharp edge to be able to cut the cord, and I've seen this cut like a little steel cable as well, so it's pretty sharp and there's a lot of force behind that. But yeah, it works when you want it to.